All right, y'all, it is 10 o'clock. I don't see any new, well, hi, James. I don't see any other new people in the last few minutes. So we'll get started. I'll ask that everybody mute who is not speaking. And welcome. Welcome to the North Texas Renewable Energy Group monthly meeting. We meet the second Saturday of each month at 10 a.m. And from this point forward, meetings will be virtual, except for field trips. And I'll have Georgianne announce after membership what our next meeting is about. Oh, good. We've got a couple of other people joining us. Curran, Paul, great. All right. I'm going to turn it over to Lissa to talk about membership.
Okay. I'm Lissa Magel. I'm the membership coordinator, and I just want to encourage folks who feel like they're getting something out of these meetings and learning and hopefully able to take advantage of our group's IO chat group. That, it costs us a little bit of money to pay for the Zoom meetings and such. So it's only $20 a year. And you can go to the NTREG website and join from there. And really appreciate everybody, joining in. And I think Georgianne may talk about some upcoming events. We occasionally have booths and we can talk to the general public. We're an educational group. We like to reach out, and generally I describe us as energy nerds. So we like to tell other people about what we do to save energy and generate our own energy, and encourage others to learn more about it. And part of it is being a member of groups like NTREG. So thanks for coming today. And I'll turn it back over.
Thank you so much, Lissa. And Georgianne, do you want to talk about next month's meeting and anything else that's coming up?
Yes, thank you. Can you hear me?
Yes.
Okay, wonderful. My camera's not working right now. So good morning, everyone. Next month, I'm really excited. Our speaker is Nathan May with the Trinity River Audubon Center, and he is going to talk about what is the connection between renewable energy and birds. I heard him at a different presentation, and Audubon Society is very strongly in favor of renewable energy. And sometimes you hear people say that renewable energy is bad for birds, and they have different ideas about that and different ways to ensure that birds are safer. So he gives a great presentation. I hope y'all can come. And then the next thing I want to talk about is we are scheduled to launch our new publication, our little micro website called The Truth About Residential Solar. And we're going to do that in mid-June. So we'll send out notices to everyone. It'll be a soft launch, meaning that we're sending out to friends so that if there's anything wrong and you find it, let us know first before we release it to the wider world. And we're really excited about it. And I just want to publicly say thank you to all the people who helped me write and edit it, especially Paul Westbrook and Eric Pratt and Tracy Wallace. And of course, our previous chairman, Randy Boys, who was the one that this project developed under. So thank y'all so much for your input. And we want to continue to get more of it when you see the final product. Thank you.
Wonderful. And do we have any announcements about upcoming booths where NTREG is going to be set up and talking to folks?
Not that I know of right now. So, but if somebody else knows one, please let me know.
Okay. So now let's move on to our speaker. We're so excited. Bill Roth is here with us today to speak about energy management systems and power control systems designed to optimize electrical power and prevent overloads. Bill is a NABCEP certified professional who began his career in project management and site assessment for residential solar in West Virginia. and he built a strong foundation across all aspects of solar installation. He went on to expand his expertise through roles in service management, technical sales, and as the primary onboarding trainer, developing well-rounded perspective on the industry. Now at ABB, as a senior application engineer, Phil leverages that experience to train, onboard, and design energy management projects along ABB's network of contractor installers. So, Phil, welcome, and thank you so much for being here. I'll turn it over to you.
Okay, yeah. Yeah, thanks so much for having me. Um, I'm hearing about your next speaker, and this presentation is really code heavy. So if anybody is falling asleep, just you know, let me let me know. But it is very code heavy. I think code is exciting. And the updates from 23 to 26 are important and significant. So yeah, without further ado, I'm gonna dive into it.
And I just, for the group, I'm sorry, I meant to say,
Oh yeah.
please be popping your questions in the chat. And then when the presentation is over, we'll go through those. And once we've gone through the questions in the chat, if you have additional questions, just use the little raise hand thing at the bottom of your screen. Thanks, Phil. Sorry about the interruption.
No, not at all. Please. I was going to mention I prefer just like interrupting style Q&A. So if anyone has anything that doesn't look right or they want clarification on, just pipe up and let me know. We don't have
We'll
to like
go with
save it
that.
for an end of presentation Q&A because I feel like people forget about stuff and
Okay.
when I want an answer, I want an answer. So I extend that courtesy to all of you as well. So, yeah, to start, we'll review the key code definitions and high-level overviews of energy management and power control systems. From there, we'll walk through some practical use cases for each, beginning with energy management concepts, and then going into the broader range of applications now permitted under power control in the 26 code. And then we'll finish, if we have time, looking at ABB's approach to energy management under the Relia Home portfolio. So yeah, like I said, it's an open Q&A. If you have anything, just let me know. So yeah, an EMS monitors and controls power within an electrical system and serves as the umbrella category for both EMS and PCS. The 2026 code clarifies that EMS functions are for purposes other than overload control. This is an important distinction. EMS is not for overload control. It's more typically for convenience or cost savings. So to avoid confusion, remember that monitoring means observing, while controlling means actively directing power flows. Power control systems, or PCSs, are a subset of energy management systems specifically for overload protection. Within PCS lies two types, single source, which is capable of load management only, and multi-source, which is capable of controlling power production sources with or without load management. So just to get started with some background, in the 23 cycle, the NAZ placed EMS and PCS together under Article 750, and the definitions were vague enough that a lot of folks interpreted EMS as being capable of performing overload control functions. In fact, the phrase EMS for overload control appeared in several sections, which created confusion about whether EMS could be used for load calculations, conductor sizing, or service upgrade avoidance. To clarify, any use case, whether that be for convenience, cost savings, or overload control, were all defined under the 23 code as EMS. In 2026, the code does a great job of clarifying what EMS and what PCS can be employed for separately. So the 2026 NEC reorganizes these systems into Article 130 and draws a sharp formal distinction between EMS and PCS. This is one of the most significant conceptual changes in the code cycle. The move from Article 750 in the 23 NEC to Article 130 in the 26 is not just cosmetic, It's a signal that energy management is becoming a foundational part of electrical system design. Just to touch on some of the important codes in the new Article 130. Article 130.1, which is not pictured, is about scope. It basically just says that the article applies to the installation of energy management systems. So I'm going to skip over that one. But 130.2 is where it gets kind of interesting. It's about listing requirements. And specifically, it says energy management equipment shall be listed to UL 916, and power control systems, which are defined in Part 2 of Article 130, must be listed to UL 3141. Because at the time of the release of the 2026 code cycle, UL 3141 is still in the outline of investigation draft form, I would encourage anyone installing PCSs in jurisdictions enforcing the 26 cycle to appeal for an interpretive exemption under NEC 90.4. There are several companies claiming UL certification, but to date, there are extremely few products that are actually listed to UL 3141 because of its draft status. So this is one of the instances where the code is actually a bit out in front of the industry. The rest of Part 1 in Article 130 is basically a direct copy from the 23 version of the NEC. It details more shall and shall nots for what energy management systems can and can't do, like overriding alternate power sources for a healthcare facility or legally required standby systems, not stuff that we'll end up talking about too much. The first code in Part 2 of Article 130 defines a PCS as an EMS that prevents conductor and equipment overloading. Article 130, Part 2 goes on to describe requirements for PCS. 130.60, new to the 2026 NEC, establishes how a PCS must perform in order to be recognized as a system capable of preventing overload. Because PCS is allowed to influence load calculations and conductor sizing, the code requires that these systems meet specific, verifiable performance criteria. PCS must continually monitor electrical parameters, typically current, power, or both, to detect when loads or sources approach the limits of the projected conductors or equipment. When monitored values approach the allowable threshold, the PCS must act quickly enough to prevent an overload. This may include shedding loads, it could be throttling loads, it could limit DER output, or it could stagger loads. The timing requirement ensures PCS can serve as a safety-critical system. The system must operate with sufficient accuracy to ensure that its control decisions are based on correct measurements. Reliability expectations include stable operation under normal and abnormal conditions, predictable behavior during transitions, and no unsafe oscillations or rapid cycling. We call them thrashing, and that's outside the conditions of the listing. If the PCS loses communication, loses power, or experiences a fault, it must default to a state that does not allow an overload to occur. Overcurrent protective devices, breakers, remain the final layer of protection, but PCS must not create unsafe conditions. Another key provision in Part 2 of Article 130 allows PCS control settings to be used when calculating connected loads or sources. The requirement means that a PCS must be able to set a specific ampere limit for every conductor, source, or load it controls, and that this limit is treated as a continuous load for code calculation purposes. In simpler terms, the PCS must let you program an exact current limit in amps for each controlled circuit, and whatever limit you set is assumed to be operating continuously when performing NEC load calculations. This ensures the PCS can reliably cap current on each protected path, and that the electrical system is sized as if that limit is always present. We'll look at some examples of this later. 130.80 deals with marking and documentation. Just like you have to label a panel anytime you install a circuit or throw up your PV disconnect label, there are specific requirements for labeling a PCS installation. 130.80 can be summarized as a labeling and documentation rule for any equipment or circuit supplied by a PCS. It ensures that anyone servicing the system understands the PCS limits, who set them, and which circuits are affected. 130.80b continues the documentation requirement for how a PCS performs its overload control function. It ensures that anyone servicing or inspecting the system can clearly understand what is being monitored, what is being controlled, and how the PCS is configured. Beyond just labeling, a PCS must have a readily available document that lists the monitoring methods, control functions, and control equipment the PCS uses to prevent overloads. It also has to have the specific settings associated with those functions, whether the PCS is a single source or multi-source PCS. And the two informational notes clarify that a listed PCS includes defined hardware and software. That does mean that in order for an inspector to properly verify safe operation and successful installation of a PCS, they will have to actually look at the commissioned software. I know that is anathema to most electrical inspectors. Sorry if there's any on the call, but it is part of the evolving code that inspectors will have to actually look at a screen to see if the settings are input correctly. When PCS control equipment isn't located where you can see the overcurrent devices it controls, the code requires a directory to be posted so qualified people can easily tell which circuits are being managed. If the PCS controller is not within sight of the OCPDs for the circuits it controls, a directory or listing must be placed on the enclosure of the PCS device, disconnect, or overcurrent protective device. This directory must clearly identify which devices and circuits are being controlled. This ensures that anyone servicing the system immediately understands the relationship between the PCS and the protected circuits. So just as an overview, here's a hierarchy tree to better visualize the differences between EMS and PCS. The umbrella category of EMS is defined as a system that monitors and controls power. PCS is specifically for overload control. Single source PCS is capable of load management only, whereas multi-source is capable of controlling power production sources with or without load management. And that is probably the densest part of the presentation, so thanks for hanging in there with me. Next up, we're going to go to some energy management applications. These are non-overload control and are really just designed for rate arbitrage. So the first and probably most common example of EMS function that we're looking at is time of use rate arbitrage. The graph to the left of the slide is an example of APS, that's the Arizona utility. It's their time of use schedule. Certain types of EMSs can employ circuit scheduling and load management abilities to reduce load or turn off power-hungry appliances during more expensive time of use periods. Customers with solar only can install an EMS to control their most demanding appliances during the time of use window to reduce load or turn off appliances altogether to provide cost savings. If the EMS that's installed can also provide PCS functionality, then the customer will be battery ready for a whole home backup. Folks that already have a solar and storage system can set the EMS PCS set point to match what their battery system is capable of, thus ensuring that they don't pull any erroneous kWh through the meter during the most expensive time of the day. Here's an example of a different type. Oh, yeah, go ahead. Oh, do we just have background noise or is there a question? Hello?
你不是昨天看了吗？我就怀疑你。
Shenru,
Shenru,
Shenru, will you please mute, or if you have a question, go ahead and ask.
我现在带3个本科生狗。你说的另一家是哪一个呢？
I'll see if I can mute him.
Okay.
There you go.
Okay, cool. So here's an example of peak shaving or demand charge management. We have the APS TOU window for winter rates, and you'll see they have a once per month demand charge of $13.74.7 per kW during the on-peak hours of 4 to 7 p.m. In this example, an EMS with circuit scheduling and power limiting can be employed to dynamically control loads under a predetermined power limit during the TOU window to mitigate the kW consumed. The screenshot to the right of the slide is from our ABB ReliaHome app, showing the power limiting feature available within our EMS solutions. So you can see when the grid is up between May 21st and October 20th, Monday through Friday, between the hours of 4 and 7 p.m., I'm setting the system to maintain a low total power limit of 6 kW, and that will prevent excess demand charges and save the consumer money. It's not an overload protection, it's just for the benefit of the end user. Similarly, EMS's use for time of use rates, or more commonly demand charges, are frequently adopted for commercial buildings. As an example, a commercial building installs an energy management system to reduce peak demand charges from the utility. When the building's total load approaches a preset threshold, the EMS automatically monitors real-time power usage across all appliances, controls selected non-critical loads, such as dimming lighting, cycling HVAC compressors, or delaying EV charging, and keeps the service from exceeding the demand limit, avoiding costly peak demand fees. This is a classic EMS application because the goal isn't overload protection, that's PCS territory. Instead, it's cost optimization and operational efficiency, exactly the kind of convenience or savings function the NEC associates with an EMS. So we've wrapped up a short section on the use cases for EMS. There are plenty more. Technically, a blind system, like an automatic blind system, that's kind of an energy management system function. There's myriad use cases for EMS. So I just want to go over a few common ones. But I do want to clarify that if your jurisdiction is still under the 2023 or previous versions of the NEC, all the use cases we're reviewing, both EMS and PCS use cases, are considered EMS use cases under any version 2023 or older. So next up, we are going to talk about some power control systems. These are delineated in the 26 code, but 23 and older codes, it's all the same, all EMS. So just to review, power control systems are types of EMS that are specifically used to prevent overload. Amongst power control systems are single source, capable of load management only, and multi-source, which are capable of controlling power production sources with or without load management. Here are some examples of what a single source power control system can look like. This is really what ABB specializes in our portfolio. On the left, we have a simple circuit splitter, which allows one or another load to operate at any given time. In the center, we have power sharing devices that monitor and control two or more loads to operate within a predetermined power limit. And on the far right, we have a panel monitoring device that monitors real-time power consumption on the service or feeder and allows a load to run so long as there is enough headroom for the load to do so. In this example, we're looking at a multi-source power control system, a system designed to manage both loads and power producing sources. In this case, the PCS is coordinating a PV energy storage system that is interconnected with the building's electrical service. The PCS continuously monitors the current on the primary service or feeder conductors, watching for conditions that could push the busbar beyond its allowable ampacity. At the same time, it actively controls the output of the PV ESS, adjusting or limiting its contribution whenever necessary. By doing so, the PCS ensures that the combined current from the utility source and the on-site generation never exceeds the rating of the busbar or upstream equipment. This setup illustrates how a multi-source PCS enables safe integration of distributed energy resources without requiring costly service upgrades or oversized equipment. It also highlights the real-time coordination between monitoring and control that defines PCS functionality under the 2026 code. This scenario builds on the earlier multi-source PCS example, but now the system is managing both a power-producing source and a significant load, which adds another layer of coordination and control. In this configuration, the PCS is not only regulating the output of the PV ESS system, but is also actively managing an EV charger connected to the same busing. Just like our last example, the PCS continuously monitors the current flowing through the primary service or feeder conductors, watching for any condition that could push the bus bar beyond its rated capacity. When the combined demand of the utility supply, PV ESS output, and EV charging begins to approach that limit, the PCS can automatically intervene. Depending on real-time conditions, it may curtail PV production, reduce or pause EV charging, or do both simultaneously. Let's shift into some practical use cases for power control systems by starting with NEC 70513, and specifically looking at how the 2023 and 2026 versions of the code differ. To set the stage, here's the exact language from the 2023 NEC. I like to put this up on the screen and pause for a moment so everyone can read through it and let it sink in, because I'm imagining that most of us have dealt with these requirements in one form or another. I know me personally, I'm very familiar with the traditional load side interconnection rules in 70512, especially the well-known and often reviled 120% rule. That single requirement has driven countless panel board replacements, service upgrades, and redesigns across the industry. Anytime the sum of the bus rating and the backfed generation exceeds the 120% threshold, the only path forward is to upsize equipment or reconfigure the system. But Section 705.13 was introduced as a way to address exactly that challenge. It provides a compliant method for connecting load-side power production sources, like PV or energy storage, even when their contribution would otherwise exceed the sizing limits established in 70512. In other words, 70513 opens the door for smarter, controlled interconnections that don't automatically force a service upgrade, and it's this concept that evolves significantly in the 2026 NEC. Now let's look at the same section as it appears in the 2026 NEC. You'll notice right away that the code language has been updated to explicitly reference this functionality as a power control system, and it now points directly to Article 130 for the governing requirements. What's interesting is the historical swing. The 2020 NEC used the term PCS, the 2023 NEC shifted to EMS, and now the 2026 NEC returns to PCS, reflecting the industry's recognition that overload prevention is a safety function, not an energy management feature. In the highlighted text, you can also see the updated listing requirements, which now reference UL 3141 and UL 1741. One important point that remains consistent between the 23 and 26 versions is the core permission. A PCS is allowed to limit the current and loading on bus bars and conductors. That wording is deliberate. It means the PCS can manage both sources, like PV or ESS, and loads, such as EV chargers, giving designers a flexible tool for keeping the electrical system within safe operating limits without automatically triggering service upgrades. In this diagram, we're looking at a service equipped with a 200 amp main breaker feeding a 200 amp rated bus bar. Under the traditional 120% load side interconnection rule in 70512, the maximum PV or ESS system you could backfeed into this panel would be limited to a 40 amp breaker, which often restricts system size and forces costly equipment upgrades. Section 70513, however, opens the door to a different approach. By using a listed power control system, the installation can actively monitor and control both power producing sources and connected loads to ensure the feeder or bus bar is never overloaded. Because the PCS continuously supervises the current flowing through the service conductors and bus, it can automatically reduce PV and ESS output, curtail loads, or take other control actions to keep the total current within the equipment's rating. This capability means you can interconnect more generation or storage capacity than 70512 would normally allow, without replacing the panel or upsizing the service. The PCS provides the safety margin by guaranteeing that the combined current from all sources and loads never exceeds the busbar or conductor ampacity. This practical benefit is significant. The electrical infrastructure can be used far more efficiently, and system designers can add larger DER systems to existing equipment. Conductor and breaker sizing are based on the PCS set point, which, per Article 120, can be as high as 80% of the main breaker rating, allowing for much larger PV or ESS systems while still maintaining full code compliance. Give me just a second. NEC 120.7 is where the code formally recognizes the use of power control systems in branch circuit, feeder, and service load calculations. This section is dense, so it helps to break it down into its core ideas. To start, 120.7 requires that any PCS used for load calculations must comply with Article 130, Part 2, which we reviewed earlier. A key requirement is that the PCS control setting, the ampere limit the PCS enforces, must be established by a qualified person, and that settings cannot exceed 80% of the rating of the OCPD protecting the monitored circuit. This 80% cap ensures the PCS provides a reliable safety margin when it is being used to prevent overloads. The code then outlines two different methods for performing load calculations, depending on what the PCS is monitoring and controlling. If the PCS monitors only the controlled loads, then the PCS control setting replaces those loads in the calculation. If the PCS monitors both controlled and non-controlled loads, then the calculation must use the minimum operating current of the controlled loads instead of their full nameplate values. The informational note is important here. It clarifies that the minimum operating current is simply a value greater than or equal to 0, representing the lowest current the controlled loads could draw. This prevents designers from assuming unrealistic or artificially low values. All non-controlled loads continue to be calculated using the traditional methods found in Article 120, Parts 2 through 7. This section of the code is especially relevant today as more installations include EV chargers, heat pumps, and other large loads that benefit from PCS-based load management. In this scenario, the EVSE has a nameplate rating of 12,000 volt amperes, and it is placed under the control of a power control system. The PCS is programmed to monitor the service conductors and automatically adjust the EVSE's demand whenever the total service load approaches the PCS control limit. Because the EVSE can be reduced all the way down to 0 output, its minimum operating current is 0 amps, which becomes important for load calculation purposes. In this example, the PCS limit is set at 80 amps, which corresponds to 80% of the 100 ampere OCPD protecting the service, exactly as required by Article 130. Because the PCS is monitoring both controlled and non-controlled loads, the NEC requires that the minimum operating current of the controlled load be used in place of its full rating when performing load calculations. Since the EVSE can be reduced to 0 by the PCS, its minimum operating current is 0, and that value is substituted into the calculation rather than the full 50 ampere nameplate rating. In this grouped load monitoring example, 3 different loads are placed under the control of a power control system, an EVSE rated at 7,680 VA, a pool pump rated at 4,800 VA, and an HVAC heat pump rated at 7,200 VA. All 3 loads are supplied from a single 40 ampere branch circuit protected by a 40 amp overcurrent device. The PCS is programmed to monitor the current on that 40 ampere branch circuit and dynamically adjust the operation of the EVSE, pool pump, and heat pump so that their combined demand never exceeds the PCS control limit. Because the PCS is providing overload protection for this branch circuit, and per NEC requirements, it cannot exceed 80% of the OCPD rating, in this case, the qualified person sets the PCS limit at 32 amps, which is 80% of the 40 ampere breaker. Since the PCS is monitoring only the controlled loads on this branch circuit, the NEC requires that these loads be represented in service load calculations using the PCS control setting rather than their individual nameplate ratings. As a result, the EVSE, pool pump, and HVAC heat pump are collectively treated as a 32 ampere controlled load for calculation purposes, rather than the much higher sum of all of their individual ratings. Article 702 covers the rules for optional standby systems, which is where most battery storage exists in the NEC now. And Section 702.4 focuses specifically on how those systems must be sized and rated. The core idea is that the standby source must be able to support whatever loads it is expected to carry, but the code treats manual and automatic systems differently. When the transfer to the standby source is manual or non-automatic, the code requires the optional standby system to have enough capacity to supply all loads the user intends to operate at the same time. Because the user is making the selection manually, they're permitted to choose which loads will be connected during an outage. But when the transfer is automatic, which is the case for most modern PV and ESS-based backup systems, the rules tighten. An automatic optional standby system must either be sized to carry the entire automatically connected load, or it must use an energy management system to automatically adjust the connected load so that it never exceeds the output capability of the standby source. This is where power control systems become essential. In the illustrated setup, a load center is backed up by a PV ESS system that also includes a PCS. The PCS continuously monitors the loads on the backup panel and actively controls them, reducing, shedding, or sequencing as needed to ensure the total demand never exceeds what the standby source can safely deliver. This allows the system to remain code compliant without oversizing the ESS or restricting the homeowner to only a small subset of loads. Okay, so that's everything we had on code. I do want to take a bit of time, if we have any, to talk about the products that ABB offers, but this is probably a good time to jump in with questions because that was a lot. Any questions on the code implications of EMS and PCS? Okay, I mean,
I think the next section is going to answer a lot of questions for those of us who are slowly electrifying everything.
Okay, yeah. So yeah, let's dive into it. So ABB does have a portfolio of products for energy management. Like I said, we really focus on single source PCS. But yeah, without just riffing too much, let me get into it. So at ABB, within our Smart Buildings Energy Management Division, our focus centers on two major goals: avoiding unnecessary service upsizes and maximizing the performance of backup battery systems. Our portfolio is built to integrate seamlessly into both existing electrical systems and new constructions, giving contractors and building owners a practical way to electrify without triggering costly service upgrades or infrastructure changes. Our off-grid manager delivers real-time power monitoring and load control and is designed to work with virtually any inverter or battery platform on the market. Beyond basic power-based control, we also support deeper energy-based integrations with systems such as Tesla, Enphase, SolarEdge, Franklin WH, EG4, and Solarc. These integrations allow the system to make decisions based on state of charge, not just instantaneous power, which leads to smarter load prioritization, longer backup durations, and more efficient use of stored energy. Real-time power monitoring lets the system constantly watch the actual load on a service or circuit. That allows it to automatically reduce or pause loads before anything becomes overloaded. Instead of sizing everything for the worst-case scenario, the system can safely operate within the limits of the existing electrical system. When running on battery, the limiting factor isn't just power, it's how much energy is left. By integrating with major inverter and battery platforms, our EMS can make decisions based on state of charge, which helps stretch backup duration, prioritize essential loads, prevent the battery from draining too quickly, and use stored energy more efficiently. This functionality provides a more customizable, stable, and predictable whole home backup experience without requiring a large and often very expensive battery backup system. So this video introduces our flagship product, the ReliaHome Smart Panel. And let me see if I can get that to play. And turn the volume down. Okay, cool. Some of you may recognize this as the Lumen Smart Panel. Lumen was acquired by ABB back in January of 2025. The ReliaHome Smart Panel is a 12-pole controller. Out of the 12 poles, 6 are rated for 30 amps and 6 are rated for 60 amps with 10 and 6 gauge wire respectively. It connects to the home's existing load center and can control up to 12 120 volt loads, or what we typically recommend, 6 240 volt loads. The smart panel intercepts the circuit between the existing breaker and the existing home run, as you'll see on the screen, making it easy to install. Each unit comes pre-wired with a set of main CTs and grid outage detection built in. And you see the main CTs go on the service conductors or feeders, and that's pretty much the whole installation. So here are some screenshots from the video showing the installation method. As you can see, all you need is some space adjacent to the panel and access to a 2-inch knockout. Really very simple, and this becomes a fully functional single source PCS. This is our new product, the ReliaHome Flex. As we dive deeper into electrification, we saw a need for a more modular solution for modern electrification issues. The ABB ReliaHome Flex system is a modular, brand-agnostic energy management platform designed to help homes add high-demand electric loads like EV chargers, heat pumps, induction appliances, pool pumps, and electric water heaters without requiring a costly service or panel upgrade. It works with any load center and installs quickly, making it suitable for both retrofits and new construction. What ReliaHome Flex is a smart home energy management system that monitors and controls selected circuits so the home's total electrical demand stays within the limits of the existing service. It uses a central hub, which you can see here, and circuit level controllers here to dynamically manage loads in real time. Homeowners can set priorities and view usage through the ReliaHome app. And I think we have a video on that as well. Kill the volume. So yeah, you can get a better view of the product here. As homeowners continue to electrify, the need for flexible and cost-effective solutions arises to address main panel and service limitations. The Flex system is compatible with any brand of load center or breaker manufacturer and consists of the hub and controllers. The hub connects to the home's Wi-Fi router and communicates wirelessly with the controllers. It is as simple as just plugging it in. Controllers are installed anywhere along the load wire, providing power for the load you want to control. Each controller can support 120 or 240 volt loads up to 60 amps. Additional controllers can be added later as new electric appliances are installed. Commissioning is done via our ReliaHome app. Flex intelligently manages loads to ensure the connected circuits stay within the electrical limits. Similar to our grouped monitoring example from 120.7, our smart algorithm ensures that the highest priority is given to in-use appliances to avoid unnecessary shutdowns. Less noticeable appliances are always shed first. Flex, like the smart panel, can be retrofit to an existing home, eliminating the need for a main panel or a service upgrade. This new product is primarily targeted for home electrification. However, we are slowly introducing battery storage integrations that will allow for state-of-charge-based load shedding with select battery partners. And that's no reason to let it finish. It's just home construction at that point. The installation can be done just about anywhere within the premises wiring. It is NEMA 3R rated, so it can go outside. It can use employ conduit, or it can just be tucked up against a joist if you have available exposed Romex wire. Just a quick overview of the installation. It really is incredibly simple. You download the Rely Home app, you plug the hub into the router, you create the system on the app, and then at that point, you choose your accessible location for the controller circuit. You cut and strip the wire to the appropriate length. Turn off the breaker first, please. And then you drill the knockouts for where you can put your stripped wire. At that point, you're just screwing down to the terminals, making sure everything's wired up, and putting the cover back on. And then here's the specifications, which I won't go over line by line, but I'll make a copy of this presentation available if you are curious. I have that for the smart panel as well. And that's all I got. If you have any questions, this QR code will automatically add my contact information to your phone. And yeah, that's it. Thanks so much for having me.
Thanks, Phil. I appreciate it. And so with the QR code is for anybody that's interested in the product, is this the way we should contact you to go through this?
Yeah, it's my direct contact. I'm available to answer questions, and of course, if you have a project that needs our products, I can point you in the right direction.
Wonderful. And installation, I'm sorry, I may have missed this when I was answering something in the chat. Does it require a journeyman or a master electrician?
Not necessarily. Our typical stance is that because the entirety of our installation does happen downstream of the service disconnect, as long as you are a qualified person and certified to be safe around live electrical components, there's no reason that you would need a journeyman or master's license to perform the installation.
Okay. Do we have any other questions?
Sorry,
I'm sorry.
I should add, qualified person does also mean that you've taken our training course, which we offer for free at anytime, anywhere. It's learn as you go platform.
Interesting. How long is the training?
Usually about 45 minutes. It's not too bad. Just an overview of the products and how they install, some tips and tricks.
Great. Do we have any?
I have a question. This is Georgianne. I'm wondering, are we going to be able to get a copy of the slides so that we can post
Oh, yeah.
it? Okay, wonderful. Thank you.
Yeah, absolutely.
Thank you.
Rosa, I had seen you come off mute. Do you have Paul, sorry.
Hi, yes, quick question on the first product you showed, not the wireless one. Is that one set up already to integrate with battery transfer switches? I've got Enphase.
Yep. Yeah, we integrate with Enphase. Yeah.
Okay.
Absolutely.
Perfect. Thanks.
This is James Ornstein. I had my hand up. One qualification on the comment about qualified persons. Mm-hmm. So in most permitting jurisdictions, you will have to have a electrical permit and sign off, and they will usually require an inspection by an electrician in order to. You can do work on your own house. You can't do work on somebody else's house if you're not an electrician. You can do your own work, but you may still have to have it inspected by an electrician.
Is that like a local jurisdictional preference?
Yes.
Okay, then yeah, obviously the HJ rules the roost.
Oh, I was curious, Phil, does the Flex, is that considered a PCS or is it still just the EMS?
So I talked about this in the early part discussing listings. Um, there's basically no products that are listed to 3141 as a PCS. The 3141 listing is still in an outline of investigation draft. Um, I don't claim to be an expert in how UL operates its business, but I know that there is this sort of shortcut UL certification that they're offering now, which is less than a full listing, but better than nothing. I think there's a few products that have gone through that process. That's a long-winded way of saying we've designed the Flex system to be compliant with 3141. The nationally recognized testing laboratory that we use does not currently test a 3141 because it's not a published listing. So we are waiting on the laboratory that we have contract with to add that testing to their portfolio, and then it will be a PCS. By listing right now, according to the 26 cycle, it is an EMS.
Okay, so it's falling kind of in a regulatory quagmire in between.
It's a regulatory quagmire. It's a good way to put it. And that's why I would say generally you're going to want to lean on jurisdictional exemption while the code is ahead of the industry. This is where articles like 90.4D, where you can say like, yes, I understand the code wants this, but the industry doesn't have it yet. So can we use the previous cycle to achieve similar safety compliance? I think that's a good use of that code.
Cool. Thank you.
Absolutely.
I had another kind of question comment if we're getting down to second round.
Yeah, please.
So NTREG is a member of the Texas Solar Energy Society, and the Texas Solar Energy Society is kind of coordinating some of the professional members, but in general, they're getting involved in the PUC of Texas has some open dockets, which they've been haven't finished up for multiple years, but they're trying to get them done this year, which address interconnection requirements and policies and procedures for distributed generation. So I was curious if ABB has been involved in that at all in general. And then one specific thing that they're contemplating requiring is allowing the use of meter collars, if you're familiar with that at all.
Very familiar, yes. So as far as I know, ABB is not involved in any of the regulatory docket discussions on the Texas PUC. We certainly have been very involved talking to different meter collar manufacturers, but don't have anything like that in our portfolio yet. We do integrate with several meter collars, or as every meter collar manufacturer I've talked to would say, meter socket adapters, meter collar is pejorative. I don't know why. Does that roughly answer the question?
Yes, thank you.
Absolutely. Also, I'm a big fan of meter socket adapters. I think it's a great technology. Also, testing in their laboratory is really fun. They basically just hang off meter sockets and see how much weight it'll hold. Very scientific.
For those of us that are not engineers, could you tell us what a meter socket adapter is?
Yeah. So if you're familiar with a traditional automatic transfer switch, it is what it sounds like. It automatically transfers anytime the grid goes out from your primary source, the utility, to your backup source, the generator or energy storage system. A meter socket adapter is like an automatic transfer switch, except it sits in between your meter socket enclosure and your utility meter. So it creates a sandwich, so to speak, between the gray box on the wall and the meter that sticks off of it. And then it allows you to isolate from the grid and use your secondary source. It's also, actually, I shouldn't say it's exclusively that because that's not even the original function. The original function of the meter socket adapter was to plug in EVs as a line side connection instead of as a load side connection, and thus avoid service upgrades. So you would almost literally plug your EV into the meter. instead of having it land on busing. Or you could also interconnect to your PV that way as well to get around load side interconnection rules. So really, really handy piece of technology. Admittedly, they are ugly as sin and they extend your meter by like an extra 6 inches or so, but as long as you don't mind a chunky meter socket, they really do some wonderful work. It's great technology.
Thank you. I may have been the only person on the call that needed that explanation, but I appreciate it.
I've done a lot of work with most of the meter socket adapter manufacturers, and it's a cool little subculture in the industry. They're doing some pretty cutting edge stuff.
My only other question is, can you give us an idea from the low end to the high end? I know it depends on what all our
Totally.
expenses would be, like what we're looking at
No,
as a layout.
we are listed for retail purchase on Amazon and Home Depot, so it's very public information.
Oh, okay.
The Flex system we sell as a kit. It's 2 controllers and a hub, and that usually retails for right around 1,000. Home Depot and Amazon differ by like $50, but that's right around where it's at. And then the Smart Panel, the legacy product, I want to say is just over 2,500 for the indoor unit, and slightly more expensive, a couple $100 more expensive for the outdoor rated unit.
Wonderful.
Generally, in comparison to this is what I typically tell contractors is that in comparison to a full service upsize, where you have to jump from say like a 200 to a 400 amp service, these are going to be a significantly more affordable equivalent for a homeowner.
Definitely. Do we have other questions?
Well, this is James again. I apologize for monopolizing the discussion, but without talking specifically about ABB products, I wonder if you have any comments on the pending standards for bidirectional EV charging, specifically the AC profile, which promises to be much less expensive than current solutions.
You know, I'll be honest. That is a touch outside the scope of my professional responsibilities. So I am not up to date here. You could actually probably educate me on it. I don't know.
I wouldn't venture to say anything either, other than that there's a UL standard that's they're trying to add some stuff to, and there's when you get involved in the automotive industry, then there's SAE standards, and there's a whole bunch of standards, but they keep on claiming that they'll have something by the end of the year. So,
and this would be a UL standard for V2X.
Well, I'm looking at specifically what they call the AC connection. So you're using an AC connection from the car, so the inverter is actually in the vehicle rather than in the service equipment in the house. So since the car already has the capability for that, then it promises to be cheaper because you don't have to have as much smarts in the house. But in order to be a usable
the inverter has not been in the vehicle traditionally.
Yeah, well,
I think it's only the what's that that gray Lego that Tesla put out. You know what I'm talking about.
Yeah, Tesla has they talk about vehicles that are ready for bidirectional charging, and Tesla is one of them. But there's a bunch of other companies that the cars have the capability, but without a standard. So like they talk about being able to plug in and seamlessly interconnect. You want to have the communication set up also, so you don't have a car that can't connect to the stuff you got at your house. So
interesting. Yeah, you don't know the listing number that they're working under, do you?
I don't remember it. I can try to look it up and put it in the chat.
Okay, yeah, I'll definitely check it out. This is not work that I was aware of. I'm one of the stakeholders for the 3141 development, so like the scope of my attention within the UL world has been very focused.
Yeah, I'm guessing it's UL 1741 supplement SC, but I'll double check on that.
1741 supplement SC. I'll check it out.
All right,
Thank you
y'all.
for bringing that to my attention.
Do we have other questions? Take these last few minutes to get Phil's contact information. And so we'll share, Phil, if you can send your presentation as a PDF, we'll share it with the group. And we have the recording as well.
All right. Oh, sorry. Go ahead.
No. Did you have something else?
No. It's just I just jotted down to send it as a PDF in my notebook, and then said okay out loud instead of in my head. I'm so sorry.
All right. Well, on a personal note, I'm super excited because we are getting an induction cooktop and stove today. And so we will definitely be looking into this. All right. Everyone, thank you so much for attending today. And Phil, special thanks to you for presenting this information. I've just thought of several people that are going to be interested in this information, the difference between the 2023 NEC and the 2026 related to this product. And anyway, we're so grateful for your presentation today.
Well, thank you so much for having me.
Yeah, and we're all a little jealous. We see you in a hoodie, you know.
No, it's like 90 degrees outside. It's just we keep it at 69 in the house.
Oh my gosh. All right. And so we will look forward to seeing everyone next month for the presentation from Trinity Audubon Center. And James, can you hang on here for a second for me to ask you a question?
Sure.
Okay. All right, everyone. Thanks so much. Have a good day.
Thank you, Phil.
Have a good one.
Oh, Tracy, what's the brand of the induction stove you're getting?
It's called Cafe.
Cafe. Okay.
And this is our big to do that we're doing. So but after lots of reading, and I love the group Electrify Now out of Oregon, and we went based on their recommendations. So anyway, we're super excited, but I have been concerned about the load, so as we've gone electric on the hot water heater a few years ago. Anyway, we are really hopeful sometime in the next year or two to add a second EV. We have a level 2 charger in the garage. So anyway, I know my husband, Mark, understands all this a lot better at this technical level than I do, but super excited, to see how long it takes to boil water for pasta.
Oh, it's surprisingly quick. I compared to a resistance electric, it's just amazingly different.
Yeah, and I loved your suggestion the other day about the single, giving it to the younger folks in our lives, So I'll be checking that out for our son and his wife for sure.
Well, I had access to lots of funds because I saw on the news there was a family or an apartment complex near the one that blew up in Oak Cliff, and they had the gas turned off, and one fellow was saying, we can't even boil water because we don't have natural gas. And I thought, well, you've got electricity. If you could go hand out 10 of them to the people in that apartment complex, they may never go back to natural gas.
Exactly.
So,
Exactly.
So we
Oh, sorry, Robert.
we installed an induction top from IKEA some, I don't know, 8, 10 years ago, something like that. And when we moved here, they had an electric, the regular electric heat elements. And the first thing Kathy said, no, get it out, put in a new induction top instead. And it's great. I recommend it to anybody who want to change.
yeah, it's really good. I'll look up the cafe. On Consumer Reports, they highly recommended Frigidaire, but they don't ever,
Mm,
none of them come in a small size. I'd like to get a 24 inch as opposed to a 30 or 36. So
right.
I'll look
Well,
up the cafe.
our oven, let me see, the oven is electric, the cooktop is gas. And the oven has been broken for like 4 years. And so we knew we needed to replace it, but